Hello everyone, hope you all are doing well. In this video, we'll discuss the third problem of Leetcode Weekly Contest 319. It's a medium level problem. The problem name is minimum number of operations to sort a binary tree by level. Sorry. So you are given the root of a binary tree with unique values. In one operation, you can choose any two nodes at the same level and swap the values. So return the minimum number of operations needed to make the values at each level sorted in increasing order, strictly increasing order, right? Now, since obviously the nodes are distinct, so that will be strictly increasing only. The level of a node is the number of edges along the path between it and the root node. So like this is given. So what it says is at this level, I just have one node. At this level, I have two nodes, 4 and 3. Just sort it. At this level, I have 7, 6, 8 and 5. And at this level I have 9 and 10. So how many swaps will be needed here to sort it? Just one swap 4 and 3. What about this one? So here 7, 6, 8 and 5. Suppose you swap these two, so it becomes 5, 6, 8 and 7. Then swap these two, so it becomes 5, 6, 7, 8. These are the minimum number of swaps needed. So this is 2 and this is 0. 9 and 10 already sorted. So how many swaps are needed? 0 plus 1 plus 2 plus 0, that is 3. Right? So it says that given a tree, for every level consider it to be independent, right? This is one array, this is one array, this is one array, this is one array, right? Similarly, if you come here, this is one array, this is one array, this is one array. So individually first do a level order traversal, and then for every level see how many swaps are needed to sort it, right? So this is what the problem is saying. Let's go with the intuition part, right? So this problem can be broken into two parts. The first part is find nodes at each level. Now what you can do, you can simply do a DFS, and in order traversal, and basically take a map. A map is something like a map of integer comma list. So this is the level and this is the nodes that you have. So if you do an level or in order traversal, what will happen? You will be at every level, you will be visiting the nodes from left to right. So that is what you want, right? That is what you want. Now the second part is this is the first part. The second part is find swaps for each level, right? Okay. So this is the first part. This is easy to do. I'll show that in code as well, right? It's simple. In order traversal, and we'll be good to go. What about the second part? This is the main thing, right? So I'll pick up one example given in the problem, and then we'll see that how can we go ahead with that, right? So if you pick up the first example, so the tree is something like at first level you have just 1, at second you have 4 and 3, at third you have 7, 6, 8 and 5, and at fourth you have 9 and 10, right? So let's pick up the complex case, 7, 6, 8 and 5, right? So what do? The indices of these elements initially are, this is present as 0, 1, 2 and 3. Now when you sort it, what will be the new indices? It will be 5, 6, 7, 8. So it will be present at 0, 1, 2 and 3. So for every number, let's write the previous and the new indices. So the new indices are 0, 1, 2 and 3, and previous for 5 it is 3. For 6 it is 1 only. For 7 it is 0, and for 8 it is 2, right? So these are the new indices, these are the old indices, right? So we need to find the minimum number of swaps, right? Simple stuff. To solve these things, go with a greedy approach. See that how many replacements you need. Now why do we need to go with a greedy approach? That is the question. Now the reason here is you want to bring this 5 to the correct position, right? This 5 has to be at index number 0. However, it is present at index number 3. Okay, what we will do? So we will we will go and see that 5 is present at 3. Okay, 5 is present at 3. So let's go at the third index and see what is present there. So 8 is present there, right? Now again, 8 should be present at index number 3, right? 8 should be present at index number 3, but it is present at index number 2. So let's see what is present at index number 2, right? You go here, you see, oh, 7 is present here, and it should be present at index number 0. And but however it should be present at index number 2, but it is present at index number 0. So again you visit index number 5 here. So you start something like this. From 5 you go to 8, from 8 you go to 7, and from 7 you go to 5. This is a cycle that you are forming. Now just see how many nodes you are visiting here, how many values you are visiting here. 5, 8, 7, right? These are the three values. I'm not considering the 5 again, because it is very much obvious that you have already visited this, right? So this is the logic. Implementation may vary, okay? So for just see in this case that the total number of nodes that you have visited, okay? So the nodes visited here is 3. So the number of swaps that will be needed will be 2, right? The number of edges, will be the number of swaps, right? Swap these two, swap these two, simple. And or for example swap these two, so whatever is the case. But that is what I'm saying. For 3 values, if you have done two swaps, then you are good to go, right? Then you are good to go. Like for example, in this case I have 5, 7 and 8, right? Initially they were present something like 7, 8 and 5. So what this problem says, you swap any two things, right? Suppose you swap these two, so it becomes 5, 8 and 7, and then swap these two, so it becomes 5, 7 and 8. So in the main logic here is start from the current element and see that at the position where it was present, what is the current element there, and keep on moving until you move to a visited node, because that visited node mean I have already processed it, right? Like for example, in this iteration we have processed 5, 7 and 8. Simple stuff, right? So how do you implement it, right? How do you implement it? So this is the main logic. So I have some elements, I start from this one. It is not being it has not been processed. Take a boolean array, that whether it has been processed or not. Let's take a visited array. Initially everything is false. If this is false, we go something like this. Go from here to here, here to here, here to here, and here to here, suppose. Okay. Now if we are present here, this we have processed. So along with this we have processed this, this, this and this. This and this are the remaining one. So suppose this element is already present at the correct position. Like for example, initially it was present at index number 1. Now after sorting also it is present at index number 1. So that you don't need to involve this number into any swaps, right? So that means just skip it and similarly move to this element. So you do this stuff, and then finally we know the exact number of swaps that we need, right? If I show you the code for the same, then just see what I've done here. So the logic was that let's look into the implementation part. So this is my main function. Just see, answer equals to 0. This variable is not needed. I just wrote it. Okay. Now you call DFS. This is my DFS function. Just see, it is doing an in-order traversal, left, right, and the logic in between. So I have a map here. I have a map here, and this is the level, and these are the values that at that particular level, right? So I just keep on doing it. So once my map is populated, I do it, right? I for every level I pass my current list and sort it. Also, this is known as cycle sort. This is known as sort of cycle sort, right? Similar logic. So I call this by passing a list for a particular level, and then what I do, just see, I find the length. I take again a map. Now why I have taken this map? Because I need to keep a track what were the initial positions of every number in that list before sorting, and then after sorting I obviously know, right? I have taken a visited array. My answer is initially 0, and just see here what I am doing. Start for all the n elements, right? So for the first element, just check if that element is already visited. Initially none of them is visited. If that element is already visited, or this element is present at the correct position, this tells me the previous position, this tells me the current position, right? If this is also true, just skip it. Else what you do, now you do the cycle sort. You start with this, right? Take j equals to I. This is my starting point, right? Cycle size equals to 0. Then while visited of j is not while visited of j is false, then what you do, you mark the current node as visited, and then you move to that node, right? Which node? So I start with this. Suppose I start with this, and I see where it was present, right? Where it was present. So it was present here. So I need to place this number also at the correct position. So from here you move here So from here you move here. Now I need to place this number at the correct position. So this is what we are doing here, and incrementing the cycle size at every iteration. Now when we come out, we see that if cycle size is greater than 0, answer plus equals to cycle size minus 1, because that is the number of edges that you have traversed in this iteration, right? And then you add it to your answer and just return it. So, and finally we get our answer, right? So this problem had two parts. First, finding the nodes at a single level, and then doing a cycle sort. So I hope this was a new concept for you. So yeah, that's it for this problem. If you find this video valuable, then please do subscribe to the channel. Also do like the video. In case of any queries, mention that into the comments. I'll revert on each one of them. Thank you. Take care. Bye bye.